I'm Anil Kumar. Welcome to my series on rational expressions. Now, this is an excellent video for students who want to understand rational expressions at a glance. We'll cover a few topics with very simple examples, mainly to understand all the concepts. I'll provide you with links to master the techniques for each and individual subheading shown here. So we'll talk about basic concepts, domain and restrictions, how to simplify and find restrictions, understand what asymptotes and holes are and how to figure them out from the given rational expression, how to add and subtract, multiply and divide rational expressions, and how to sketch graphs. In addition to this, we're also looking into application word problems. So we'll add applications. Right, so that is another thing which I'm going to introduce here. Before we get into all this, what you should know, that is kind of very important. So you should know this. That is basically factoring. Now, factoring techniques is a must to know before getting or understanding rational expressions, right? So I'll provide you with a link on factoring techniques that should help you in case you need to brush up. Now let's talk about rational expressions. Basic concepts about rational expressions. Rational expression is quotient of two polynomials. So that is our definition. It is quotient of two polynomials. Now what does it mean? So if I have R, let's say R of x, it is quotient of two polynomials. Let's call this a polynomial in the numerator and a polynomial in the denominator. Right? And of course, when you divide, then you know Q of x, which is a divisor here, should not be equal to 0 since division by 0 is not permitted. Now, this definitely leads to restrictions, right? So we are in the definition itself saying we have restrictions. So what are the restrictions? Restrictions are that Qx is not equal to 0. Perfect. So that is what it is. So give you an example of rational expressions will be something like this. If I have like x plus 2 over, let's say, x minus 3, it is a rational expression, right? I could have a quadratic equation here divided by something, let's say even a number 5 or 5x squared. That becomes a rational expression, right? So these are rational expressions. Now let's talk about expressions which are not rational expressions. Can you give me some examples? So get back to polynomials. We know rational expression is always ratio of polynomials, right? So if I write square root of x over square root of x minus 1, that is not a rational expression. Or if I write sine x over 5x plus 2, this is not a rational expression. So these two are not rational expressions, but these are rational expressions. Does it make sense to you? Correct? So that is the basis, right? That is the basis. Now, based on this, here is a question for you. Is quotient of two polynomials a polynomial? We are saying quotient of two polynomials is a rational expression. The question is quotient of two polynomials a polynomial, right? So write down and explain your answer. Okay, so that is how we have a format. We'll talk about the concept, and once we are done, then we'll take up a question based on it. Now let's get back to the second page, which is really this one. Okay, now here, how to simplify and find restrictions. So what we said in our definition was that a rational expression is basically a ratio of two polynomials, correct? So whenever you divide polynomials, you do not get polynomials. Let's be very clear about it. You get a rational expression, okay? Because you can't have anything in the denominator, polynomial in the denominator. Perfect. So we know here that qx is not equal to 0. So that leads to restrictions, right? Now, I hope you know all your factoring techniques. We have taken very simple examples to begin with, and we will see how to find restrictions. So here are three examples. Let's work on them. First one, 4 minus 6x divided by 3x minus 2. Now, I can take 2 as a common factor, correct, in the numerator. So if I do that, I'll write this as 2 minus 3x, right, divided by, here, well, there is nothing common, so I get 3x minus 2. Now this is your first test. Do we have a common factor here? Can I divide 2 minus 3x by 3x minus 2? That's the question. Yes, I can. Let me show you, since this is kind of very important. Some students don't just get it. So if I take minus common, I get 3x minus 2. Do you see that part? And then in the denominator, I do have 3x minus 2. Now simplification really means that whatever can cancel out, you should cancel out. So in this case, we cancelled out 3x minus 2 from numerator and from denominator, and we are left with minus 2 as our answer, right? So this particular expression, a rational expression, could be written as a constant minus 2. Perfect. So this is one part which we are talking about is simplification part, right? So that is simplification part. Now the second part is on restriction, very important. Now the restriction is that the denominator cannot be 0. So what value could give you 0 here? So well, x is not equal to what? If I write x as 2 over 3, then I will get a 0. So x cannot be 2 over 3. Does it make sense? So whenever you simplify, you have to write along with minus 2 that x is not equal to 2 over 3. Is that correct? How did we get it? At times you could do like this. You could do 3x minus 2 equals to 0. So we have 3x equals to 2. X is equal to 2 over 3. Now that is making denominator 0, which is not possible. So we get our restriction that x is not equal to 2 over 3. Is that clear? So I hope this step is absolutely clear. Now this is a very, very important aspect of understanding rational expressions, right? So let's move on. Now with slightly difficult question, we have x squared minus 81 over x squared plus 16x plus 63. I would like you to pause the video now, answer this question, then look into my suggestions. Well, we have difference of squares in the numerator, x squared minus 9 squared. So I could write this as x plus 9 times x minus 9. And in the denominator, what do I have? Product and sum. Coefficient of x being 1, 63 is 7 times 9. That can work for us. We have x plus 7 times x plus 9 in the denominator. Now you have to be really good at factoring to begin with rational expressions. So my suggestion still is that if you're not understanding what I'm doing here, you should actually watch some videos on factoring techniques, okay? Now let's move on and write down this in a simplified form. So as soon as you get common factors in numerator and denominator, you can cancel them and then write down your answer, which is x minus 9 over x plus 7. Now sometimes the communication question here is this expression x squared minus 81 divided by x squared plus 16x plus 63 equal to x minus 9 divided by x plus 7? The answer is yes or no. I think it is no. Until I write here that x is not equal to -7, and -9. So once I specify that we do have a restriction here, then they are exactly same. If I write this alone, then the only restriction is that x is not equal to -7. You understand? That is kind of very important, right? So again, getting back to restriction, we will see the common factors and we'll say, well, x plus 7 should not be equal to 0 and x plus 9 should not be equal to 0. So x is not equal to -7 and x is also not equal to -9. So we have two restrictions here. X is not equal to -7 and -9. Clear? Even though it cancels, we have to include it in our restrictions. Okay, so that is very important to understand. Now, the last question here is 2x squared plus 7x plus 3 divided by 4x squared plus 2x. Now here, the coefficient of x squared is not 1. So we look for product and sum techniques, right? 3 times 2. So we're looking for product of two numbers as 6 and the sum of these two numbers as 7. So the numbers are 6 and 1, right? So 6 and 1 will work. So let's see how to factor this. So I could write this as 2x squared plus 6x plus x, that is 7x, right? Plus 3 divided by, in this case, I can take 2x as a common factor. So I get 2x plus 1. Now I could write this as, taking 2x common, we get 2x here and we get x plus 3. We have already x plus 3 as the other two terms. Now we have 2x times 2x plus 1, right? I think it was 1, right? 2x plus 1, and now we can factor out x plus 3 and we get 2x plus 1 in the numerator also. So we have 2x times 2x plus 1 in the denominator. Now here is something very important I want to share. Before I cancel, it's a good idea to write restriction. We say x is not equal to 0 and also minus half. In that case, you don't miss out, right? And now you cancel. So you can now cancel, and once you cancel, you write down your answer, which is equal to x plus 3 over 2x, where x is not equal to 0 because that makes 2x as 0, and it's not equal to minus half. That could make the other factor 0. Perfect. So that is how we are going to solve these questions. Now let's look into the questions for you. Question number 2. Write a rational expression with no restrictions, right? That is critical. And question number 2b is simplify and write the restrictions for 2x squared minus 8 over x plus 2. Perfect. So these are the two questions for you on this topic. Now we'll try to understand a very critical topic on rational expressions, and that is asymptotes and holes, right? Basically, these are types of discontinuities. We see them especially when we are going to sketch a graph for a rational expression, which is also a part of our exercise, and we'll look into it with an example almost at the end, right? Now let's try to understand the concept. So the concept here is, as we said, a rational expression could be written as a ratio of polynomials. Let me write down one polynomial as x plus 1, the other one as x plus 2, and let me divide this by x plus 1 times x minus 1. Now as soon as I write like this, we know we have restrictions, right? So we say, well, this polynomial has restrictions. And what are the restrictions? Now restrictions are that x plus 1 cannot be 0, so x is not equal to minus 1. Also, x minus 1 cannot be 0, so that means x is not equal to 1. So we have two types of restrictions here. Both of them are actually giving you zeros for the denominator, right? From the very basic definition, denominator cannot be 0. But see what happens. If I go to the next step of simplifying, then I will actually cancel one of these terms. And as soon as I cancel this, I get x plus 2 over x minus 1. So I'm left with, in my final expression, a simplified version, only one restriction in the denominator, right? But if this has to be equal to that, I have to definitely write here that x is not equal to even minus 1. From here you can see that x is not equal to 1. But since we cancel these two factors and they do not appear here, we have to write that x is not equal to minus 1. Only then this expression is equivalent to what we started with. Now you will actually get an idea here that these two numbers lead to different kinds of restrictions, right? Now this exists even now, that means this one, right? And the other one got cancelled out. So this one cancelled, right? Why? There was a common factor in numerator and denominator. Okay, let me extend. So there was a common factor in numerator and denominator. Now these kind of restrictions lead to holes. We'll see in later examples how to represent them on a graph. But you should understand that those which cancel out lead to holes. Perfect. And those which remain, they lead to vertical asymptotes. Right. So this is the other kind of restriction, and they lead to vertical asymptotes. Is that clear? Right. Now we'll look the effect of both of them when we sketch graph. Right. So bear with me till then, and soon we are going to do that. Here is a question for you. Question number 3. How many of the following equations will have vertical asymptotes? There are 3, right? So you may have to work a bit, understand this, and what are you checking here for? You are checking for common factors in numerator and denominator. And these common factors will lead to common factors in numerator and denominator will result into holes. Let me remind this. And then that's a hint, okay? This is a hint for you. Then you answer this question. Very critical to understand. In the very beginning, if you understand these concepts, rational expressions and then rational functions will be very simple for you. So I have an example for you, and we'll try to understand the concept by solving this example. So it is 2 over 5 mn minus 3n plus m squared divided by 2m cubed plus 2. Now here we need to add 3 and take away all this from 2 over 5 mn. Now before we begin to solve this particular question, let us get reminded of what we did for fractions, since this is a very important question to be answered and understood, right? So we'll get back to rational expressions once we review what we did with fractions, right? So let me take an example here. Let us say we want to add 1 over 45 with 1 over 30. Right? How do we do that? Well, step number 1 for us is to find factors of 45 and 30, right? So what are the factors of 45 and what are the factors of 30? To get the factors of 45, we at times will do prime factorization, especially when there are big numbers, right? So we say this is 5 times 9, and 9 could be factored as 3 times 3, right? So once we do that, we know 45 could be written as 3 times 3 times 5. Similar operation we'll do for 30 also. We say 30 is 3 times 10, and 10 could be written as 2 times 5. And therefore, I could also write 30 as 2 times 3 times 5. Next operation is to find the lowest common denominator, right? So the lowest common denominator is seen from these factors. As far as 3's are concerned, we have 2 3's in 45. So we use 3 square, or you can write 3 times 3. And 5, there are both have 1 5. We take a 5. 2 is there in 30 but not in 45. So we'll take a 2 also. So 5 times 2 is 10, and this is 9. That gives us lowest common denominator of 90. Correct? Now once we get 90, we know exactly that I should be, we should be writing 1 over 45 with denominator of 90, and also 1 over 30 with denominator of 90. We could do that by multiplying 45 by 2. I have to multiply numerator also by 2. Right, to make it the same thing. Multiplying, dividing by the same number is as good as multiplying by 1. And in this case, I have to multiply and divide by 3. So once I do that, I get common denominator of 90. In the numerator, for 45, I get 2. And for 30, in the numerator, I get 3. When we add them, we get 5 over 90. Right? So we have actually added them. Next step is to simplify. I could divide both by 5 and could write this as 5 over. When I do 5 times 1, I get 5. 40 is 8. So 1 over 18. So I get my result here as 1 over 18. Does make sense to you? So exactly these steps will be done whenever we add or subtract rational expressions. We need to find common denominator. Correct? So let's decide what is the common denominator for all these terms. So that is our first step. So lowest common denominator is, we have 5 here, we have 2 here. As far as numbers are concerned, we need to take 10, right? So we'll take 10, 5 times 2, just as we multiplied this 2 with all of them. You get the idea, right? So 10. We took 5 from here and 2 from there. We just wrote 10. As far as m is concerned, we have a bigger m here, m cube. So we'll take m cube. Right? So this is already included. Once I take m cube, n is not there. So we'll take n also. So that becomes our lowest common denominator. Now that really means that I have to write all the 3 terms with the denominator of 10m cube n. We are given 2 over 5mn. To make it 10, what will I do? Well, we have to multiply denominator by 2, right? So we're talking about denominator first. We have to multiply this by 2, we get it 10, m by m square. So these are the 2 terms which we consider. So we have to multiply by the same thing also, right? Does it make sense to you? So that is how we change the first term, ensuring that we have a denominator of 10m cube n. Perfect? Next term here, negative. We write down the term which is 3n plus m square divided by 2m cube. Now here we want to get 10, so I have to multiply by 5. Well, I wrote 10. I could have written 5 times 2. It becomes easier to work, right? So better could have been writing this as 5 times 2 times m cube n, right? So we know we have a 2, but we do not have a 5. So we write 5, okay? M we already have, n we don't have, so we'll put this. So we'll multiply and divide by 5n, right? And then next term is 3, which has a denominator of 1, so we don't even have to think. We have to get all these terms in place, right? So we'll multiply with 10 m cube and n, and we'll also divide by 10 m cube and n. Correct? So still our rational expression is exactly same as it was, because in each expression we only multiplied by 1. Perfect? So this is a very important step. Now, since we have a common denominator, which we could write like this. This is the common denominator, right? Everything, this 10 m cube n becomes the common denominator for all the 3 terms. And in the numerator, we have to multiply individually, right? Just as we did here, 2 times 1 and 3 times 1. So we'll do the same thing. We get 4m squared from the first term. Now in this particular thing, is like very important to understand that 5n actually multiplies to both of them. We have to apply distributive property, right? Otherwise you'll do a mistake, right? So we have to multiply it with both to get our answer, correct? So we get 5 times 3, and also the sign negative. So, or you just put negative here and put a bracket. That'll be safe for now. Then in the next step, you can open the bracket. So 5 times n times 3n will become 15n squared. When you multiply this, it becomes 5. I'm sorry, let me write plus first. It becomes 5. We write numbers first, right? We can write m squared n. So that is what it will be. And close the bracket. Now the next term for us is 3 times all this. So it becomes 30 m cube n. Perfect. At this stage, we have to look for common terms if we have any to combine. Now, if you see this, literally, there are no common terms, right? So there are no common terms in this. So we'll just open the bracket and rewrite. At times, you will have common terms, okay? So this is just an example to illustrate the process. Okay, so when we open this bracket, signs will change. We'll have minus 15 n squared, and this is also minus 5 m squared n, and that is plus 30 m cube n, and the denominator is 10 m cube n. Is that clear? So that is the first part, and that is we have added and subtracted our rational expressions. The second part here is to write restrictions, right? So don't forget that. It is not specified, but you need to state restrictions. I'll say state them always. Right? So in rational expressions, remember, by definition, we are dividing two polynomials and the denominator cannot be 0. So whether it is included or not, you have to state restrictions, okay? Now here, the denominator has got two variables, so m cannot be equal to 0 and n also cannot be equal to 0. Perfect. So that completes our work. As you can very clearly see, when we talk about rational expressions, we have these variables. In fractions, no variables. That is arithmetic part, correct? So now once we move into algebra, we work with variables and the term rational expressions, correct? So I hope that is absolutely clear. Now here is question number 4, which is for you to do. Simplify and state restrictions. So we have a subtraction example here and a addition. I'd like you to copy these questions, answer them. Now let's talk about multiplication of rational expressions. We need to multiply and write restrictions for 2x plus 6 divided by x squared plus 7x plus 10 times x squared plus 3x minus 10 divided by x squared minus 4. So by now you have clearly all the ideas about rational expressions. You can actually pause the video, answer this question, and then look into my suggestions. First step will be to factor, correct? So 2x plus 6, I could factor 2 and I get x plus 3 there. In the denominator, we need product of 10 sum of 7, 5 times 2. So we get x plus 5 times x plus 2. And we need to multiply by the other term, rational expression x squared minus 4, which is difference of squares. We write this as x plus 2 times x minus 2. Numerator minus 10 as the product, and we want plus 3, so it will be now x plus 5 times x minus 2. Okay. So those are the terms which we get. Now, as soon as you write down your expression in factored form, it's a good time to write restrictions. So at this stage, you should write all the restrictions. So x is not equal to what all? This denominator will be 0 for minus 5 and minus 2. So we'll write minus 5 and minus 2. Here, minus 2 and plus 2. We have already included minus 2, so we'll include plus 2. So it has 3 restrictions. X cannot be 5, 2 negatives and 2 positive, right? Now we need to simplify and we can cancel out some common terms. X minus 2 cancel. Is there any other term? Yes. We could also cancel from here to there. It's like all numerator and all denominator is kind of same thing. So I hope that step is absolutely clear, right? You cannot cancel these, they multiply and become square, okay? So what we get here in the numerator is 2 times x plus 3, and in the denominator we get x plus 2 times x plus 2, which I could write as x plus 2 whole square. Is that clear to you? So that is our answer. We have already stated our restriction once, that is enough. We need not write everywhere, right? So that is how we will do it. Now based on this, we have a question for you. You need to multiply and write restrictions for something like this, right? So we have numbers here also. So you could simplify this by cancelling out the common factors, correct? So I hope that is clear. Let's move on and see division of rational expressions. To divide rational expressions, we again do similar to multiplication. You know, division is a reciprocal of multiplication. But in our case, what we will do here is first we will factor, okay? So we have a square plus 5a minus 14 over a square plus 8a plus 7. We need to divide the first term by a square minus 4a plus 4 divided by 3a square minus 6a. So we are looking for a product of 14, sum of plus minus 14, sum of plus 5. So I could write this as 7 times 2, 7 positive, 2 negative, right? So a plus 7 times a minus 2. That becomes the numerator. As far as the denominator is concerned, 7 times 1, so we get a plus 7 times a plus 1. So that is the first term, divide by this term, which is a square minus 4a plus 4. So that is, you could write this as 2 times 2, and we need minus 4. So that means both negative. So I could write this as x minus 2 whole square, right? And in the denominator, we have 3a common. We are left with a minus 2. So you really need to be an expert in factoring whenever you're working with rational expressions. Now, we'll go one more step and then we'll cancel and write our restrictions, okay? Because I want to make a point clear here, which will be absolutely clear if I move on to next step. So we have a plus 7 here, and then we have a minus 2. We're dividing this by a plus 7 times a plus 1. Now division and multiplication are reciprocal, right? So I will change division to multiplication, flip this over. We get 3a times a minus 2 divided by a minus 2 whole square. Is that clear to you? Correct. Now let us concentrate on restrictions. Now this is very important. What values can a not take? So a is not equal to what? So when you begin with the first term, you know, these values are forbidden. You cannot have 0 in the denominator, so minus 7 and minus 1. When you look into this, these are not allowed. A cannot be 0 or 2. So we get 0 or plus 2. Well, when we flipped it, then the numerator came in the denominator. Do you understand? So that means a cannot be 2, which is this restriction should also be included. Well, in this particular example, it is already there and therefore we are not including. However, as far as the divisor is concerned, you have to look for restrictions from both. You understand? So check restrictions from both numerator and denominator. does make sense. In this particular example, 2 is already taken and therefore we are not adding because it's already there. But that is an important criteria to always keep in mind, right? So this is extremely important. Now we'll cancel and simplify, okay? So what all can be cancelled? We can cancel this, and then from here we have a minus 2 which cancels one time, and then from here also it cancels. Do you see that? So we could cancel from any numerator position to any denominator position. So we are left with 3a in the numerator divided by a plus 1, and we have restrictions that a is not equal to, so we have all these terms, right? So minus 7, minus 1, 0 and 2. Got it? That is how you're going to divide. So factoring is the first step. Then convert division to multiplication by making it a reciprocal. Write restrictions. While writing restrictions, you have to consider restrictions of numerator of divisor also, since it comes to denominator. Perfect. Now this is a question for you to practice. Divide and write restrictions for x square minus 9 divided by x square minus 4x minus 45 divided by 5x square minus 15x over 3x square plus 14x minus 5. Okay. So with that, we have covered most of the portion which we wanted to do in regards to rational expressions. We understand the very basic concepts. We know how to find domain and the restrictions. We know how to simplify these rational expressions. We understand what are asymptotes and holes. We also know how to add and subtract and how to multiply and divide rational expressions. Now we will look into sketching of rational expressions and some word problems relating to applications. Let's take a small break here, enjoy the nature, and then get back to the advanced part of rational expressions. Thank you. Majestic. Beautiful. I hope you enjoyed the break. We really have beautiful weather and excellent wilderness all around. Now, with fresh mind, let's see how to sketch rational expressions, and then we'll later see some word problems. The question here is to sketch these three graphs. So I have selected the examples so that you get a variety. We'll see about the holes, asymptotes, and at times rational functions may not have any restriction in their domain, right? So those are the things which we'll see while sketching the graphs. First one here is 4x plus 12 over x squared plus x minus 6. So our step will be to factor numerator and denominator, so we get 4 common, x plus 3, right? In the denominator, minus 6 means 3 times 2, 3 positive, so we'll say x plus 3 times x minus 2. Now clearly we could actually cancel out x plus 3. So that should lead to what? That should lead to a whole, since we have a common factor, correct? So we could write this as 4 over x minus 2. So what you learned in our second part of the video was about holes and vertical asymptotes. So from here we do have two restrictions, that x is not equal to minus 3 and 2. Now since these cancel away, we can say we have a hole at x equals to which point? Minus 3, correct? So at minus 3, which x it as a whole, what is the y value? If I substitute minus 3 here, I get 4 over minus 3 minus 2, which is minus 4 over 5. Do you see that? So that becomes the position of hole in our graph. Now that is kind of very important to understand. Now let us see how to sketch it. Now I'm not really getting into major details of sketching. There is a lot to be learned from the basics we are talking about. So I'll put here basic. Okay, and I'll provide you with links into the sketching real rational expressions. A lot goes into it. Okay, now let us see now. We have a vertical asymptote which is at what point? X equals to 2, right? So we have a vertical asymptote at x equals to 2. It means that x equals to 2 is not in our domain, right? So that is our vertical asymptote. So we can also say domain is all real numbers but not x equals to 2, right? One. Second, at minus 3, we have a hole, right? So at minus 3, there is a hole which is somewhere here, minus 4 over 5. So somewhere here, we have a hole here, right? So that means this point is also not in our domain, correct? Now to sketch this particular function, what we could do, some simple calculations, right? There's a lot, as I said, about it. We could calculate the value, what is the x, when x is 0, that is y-intercept we could calculate. So if I put x equals to 0, I get a value which is y equals to 4 over minus 2, which is minus 2. Is it okay? So at x equals to 0, we have a value which is minus 2, which is going to be somewhere here. Now based on this calculation, we get a graph which will be kind of like this. On the other side, you could take some more values, and then what you find is that the curve will be kind of like this. This value we just calculated to be minus 2. And this value here is what? This is at minus 3. The value of our rational expression is minus 4 over 5. And that is how you represent a whole, right? So the idea here is to show you how to represent a whole and how to represent a vertical asymptote. In this case, equation of the vertical asymptote is x equals to 2. Does make sense to you? So this is our y-axis, this is the x-axis, and that is how we could actually sketch the given function. To get more points and accuracy, plug in the values of x as 3, 4, right? And some other values and get your curve. It should look like this. Does make sense to you, right? So we'll just give that much to our sketches, and I hope this is good enough at this particular stage, right? Now, next one here is 4 over x squared plus 1. This is already a simplified version, right? Do we have any restriction here? No. So we have no restrictions. Here x belongs to real numbers, and that is the domain. Do you understand? In this particular case. So let me just make a boundary here. These are very, very important examples. So in such a case, what you really could do is we'll sketch it using a different technique. We'll say, well, let me first do the first part of sketching x squared plus 1. Right? So we could do x squared plus 1, which will be graph like this. And let's say like this. Now we do 1 over or 4 over. So 4 over will be, this point here is 1. When I multiply by 4, it becomes 4, right? And so when I do 1 over, when you're dividing by a large number, then 1 over large number is very small. So the graph which you actually get in this particular case will be kind of like this. Very interesting, right? Now, as you can clearly see here, the value of 4 will be the maximum value. So when I substitute x as 0, I get 4, and that is my y-intercept. But when the x value is very large, we say when x is approaching positive or negative infinity, y is approaching 0 from the positive side. So that is at the later stage, we'll get into these details also. But from here, you can see that when x is very large, then 4 divided by a large number, which is always positive in this case, will be approaching 0 from above. Right? So that is how we sometimes say, and this is actually called horizontal asymptote. To know more about horizontal asymptotes, you can look into my videos, type in Anil Kumar horizontal asymptotes playlist to see many videos on this, right? Now let's move on and take the last example. But this was a very critical example where I've shown you that without restriction, we could have rational expressions. And it was a part of your question earlier. Okay. The last one here, I think you should try on your own. Here is a quick solution to the same. 3 is a common factor, so we get x squared minus 9, which is the difference of square, x plus 3. And so we get 3 times x plus 3 times x minus 3 over x plus 3. So in this case, we have both whole and no vertical asymptote. It's a straight line. Do you see that? Oh, that's good. So what we have here is that we have a whole in this case, and whole is at x equals to minus 3. So when I put minus 3 in my expression, I get what? 3 times minus 3 is minus 6, and minus 6 times 3 is minus 18, right? So that's what I get at x equals to minus 3, correct? So let me rewrite this particular expression here as 3 over x minus 3, okay? So it just looks like a linear expression. Now the question for you also here is this equal to that? No, you have to write the restriction, which is x cannot be equal to minus 3. We have a whole at minus 3, right? So here x is not equal to minus 3 is your restriction. Is that clear? Let's try to sketch this graph. Okay, so it is like a straight line. You can see 3x minus 9, right? So 3x minus 9 is your line, but at minus 3, it has a restriction. So let me extend this. Okay, so basically we're trying to sketch the function, which is, let me write like this, 3x minus 9, okay, where x is not equal to minus 3, since we have a whole there, right? That's what it is. Okay, so at minus 9, we have so we'll do like this. So we have a y-intercept at minus 9, so we'll go like this. I think I have enough space here, so I'll make that whole, right? And then I'll continue. and sketch the line. Now that is how this graph is going to look. Now this particular point here represents the hole. And the coordinates for the hole are as calculated -3 -18, which you could calculate from the final expression, right? This is your final expression. The y-intercept is -9. Perfect. So that is your sketch for the given function. Is that clear to you? So it actually gives you a fairly good idea about sketching rational expressions. There are only very few videos which could beat this part of complexity, right? With simple examples, I could give you all the flavor of rational expressions and how they could be sketched. Question number 7 here is write restrictions and sketch graph of 3x squared minus 27 plus 3. Oh, I gave you the same example. Oh my God. Okay, so we'll just change this. Okay? So we'll make it what should I do? Okay. So we'll change this and we'll make this as a cube. Okay. So we'll make it a cube. That should be very interesting. So I've changed the question. It is x cubed plus 27 over x plus 3 for you. Now that's a difficult question. Now what is a cubed plus b cubed? Let me give you this expansion also. A cubed plus b cubed is a plus b times a square minus ab plus b square. That should help, okay? So new question for you, x cubed plus 27 over x plus 3, and that is the expansion for the numerator, so you could factor and then get your graph, okay? So I think that should be very interesting. Now let us look into situations where we could have rational expressions. Now it's a very common practice to get work done type of questions, right? Or rate of change. Even in distance, if you see speed or time, that is a ratio of distance over the other thing. So you get a variable in the denominator that leads to rational expressions. Perfect. So there are many examples where rational expressions fit in. So we have a question here to work with. Sophia bought a case of books for $450. She kept 2 for herself and sold the rest for $560, making a profit of P dollars. On each book, write an expression for the profit P. That is the first part, right? Okay, part B, actually I've given it for you. Solve the equation if P equals to 10. Answer is 18. And question 8B here is, a gardener can mow a lawn in 9 hours. When his assistant aids him, it takes the two together only 6 hours to complete the job. How long does it take the assistant to mow the lawn by himself? So that rings a bell, right? So there are many questions where we could use rational expressions, correct? So wherever the rate comes into picture, we may have to use rational expressions. So it is a very important topic to consider. Let's actually get to the equation part of rational expressions. We are talking about expressions, not equations. So we'll move to equations in the next chapter. Right? So that is why the question here is, Sophia bought a case of books for $450, kept 2 for herself, and sold the rest for $560, making a profit of P on each case. Write an expression for the profit, right? So you just need to write an expression for profit. And in the next video, we'll look into equations and then we'll solve many such questions, right? So you could practice. Once we get an expression, you can always put the value of P equals to 10 and get the answer as to how many books were there in the case, okay? Okay, let's try to figure it out. So Sophia bought a case of books for $450. She kept 2 for herself and sold the rest, making a profit of this. Write an expression for this. So how many books did she buy? That is what a part of it, right? So solve this equation if P equals to this for how many books. Did Sophia buy? Okay. So that should have been the question, correct. So I was just trying to figure out this. So what we don't know is the number of books, right? So that is what it is. So let us say, let's try to answer this question, right? So we say let X be the number of books purchased. Correct. Now, since the purchasing price total is 450, right? So we say the cost price here is how much? So X books are purchased for $450. So it is 450 divided by X each. That is the cost price for each. Now it says she kept 2 for herself. Okay. So she kept 2 for herself. That means if X was the amount, rest means what? Rest means X minus 2, right? Were sold for $560, right? So in that case, the selling price will be how much? Selling price will be, the cost is 500, selling price is 560, but only for X minus 2. Do you see that? So that much each. So the expression for profit, which basically is selling price minus cost price, should be what? Difference of these two. So we get 560 divided by X minus 2 minus 450 divided by X. Perfect. So that becomes your profit P. So that becomes the expression for profit. You get an idea. So that is how we could actually get our solution to many questions relating to rate, work done, right? Now, I think you got good knowledge about this. You could solve this equation with P equals to 10. Expected answer is 18. And then you can also work with another question, similar kind. A gardener can mow a lawn in 9 hours when his assistant aids him. It takes two together only 6 hours to complete the job. How long does it take the assistant to mow the lawn by himself? So I'll provide you a link here for the solution, right? And in the next part 2, we'll look into rational equations, where we'll begin from this point. I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.